आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Everyone, so the question is, if sine of alpha is equal to a sine of alpha plus beta, where a is not equal to 0, which of the following is not the value of tangent of alpha plus beta? We're having 4 options. We have to calculate the answer and then take which of the following option is the correct option. So here we will be using this identity, that is tangent of a plus b, which is equal to tan a plus tan b. It is b, not beta. Tan a plus tan b upon 1 plus tan A tan B. Through small error, it is not plus, it is minus in between in case of this identity. So it is 1 minus tan A tan B. This is what we will be using. Also, we are given one more thing, that is sine of alpha is equal to A sine of alpha plus beta. We know this identity, that sine of A plus B, that is equal to sine A cos B plus cos A sine B. Using it in the above equation, so equation becomes sine of alpha is equal to A sine alpha cos beta plus cos alpha sine beta. Now, what I'll be doing here is that this is like this. So I'm multiplying this a inside. So that is sine alpha is equal to a sine alpha cos beta plus a cos alpha sine of beta. Now, proceeding further, I'll be taking sine alpha common. So I get 1 minus a cos of beta. Let it be equation number 1. Cos beta is equal to a cos alpha sine beta. Now I'll be dividing whole of the equation by cos alpha. So I get tan alpha into 1 minus a cos beta is equal to a. So here I get a sine beta. So therefore, what is the value of tangent of alpha? So tangent of alpha is nothing but it is a sine beta upon 1 minus cos of beta. Let it be equation number 2. Now, getting back to equation number 1, again, what I'll be doing here is that I am dividing whole of the equation by cos beta. So I'm writing down dividing 1 by cos of beta. So if I'll be doing that, what I get in the equation, I get sine alpha upon cos beta, which is equal to, I'm taking a common, so that is sine alpha plus cos alpha tan beta. How tan beta? Because it was sine beta already here. So sine beta upon cos beta is equal to cos alpha. So that is cos tan beta. So cos alpha tan beta. It is like this. Now proceeding further, what I am doing here is that I am cross multiplying it again. So it is sine alpha is equal to a sine alpha cos beta plus cos alpha a cos alpha cos beta tangent of beta. Now, from here I can find out the value of tan beta. So what would be the value of tan beta? Tan beta would be equal to sine alpha. I'm taking common. So sine alpha into 1 minus cos beta, 1 minus a cos beta in the numerator, and in the denominator what I get a cos alpha cos beta, this thing. So it is a cos alpha, cos beta. Let it be equation number 2. Now, I'll be using this identity, which I have mentioned in the beginning of the question. So there'll be two cases. In the first case, I'll be using this as tangent alpha and I'll be using this as tangent beta. Now, the question is if I'm using this as tangent alpha, then what would be the value of the tangent beta? So here I'll be using tangent beta. That is the simple sine beta upon cos beta. In first case, I'll be using these two values. And in the second case, if I'm using this, then what would be the value of tan alpha here? It would be tangent alpha is equal to sine alpha upon cos of alpha. So in this way, we'll be calculating in two ways. So firstly, let's consider the case number 1. So in the case number 1, I'm using tangent of alpha, that is equation number, this is equation number 3. So I'm using equation number 2 as tan alpha, and what is tan beta? Tan beta is sine beta upon cos of beta. So I'll be using it the formula. What is the formula? It was tangent of alpha plus beta. I'm using the above formula which I've mentioned in the beginning of the question. What is tan alpha? Tan alpha is what we have calculated, that is a sine beta upon 1 minus a cos of beta plus sine beta upon cos beta. This is in the numerator, and in the denominator it is 1 minus, that is 1 minus tan alpha, that is a sine beta upon 1 minus a cos beta into sine beta upon cos of beta. Now what we'll be doing in the next step, I'll be taking the denominator. Now there is one thing which is to be noted, that in denominator we'll be taking in the numerator also the LCM is, we'll be taking the LCM. So it is cos beta into 1 minus a cos beta, also denominator it is the one and the same thing. So these will be ultimately cancelled out. So what I'm doing here is that I'm writing only the remaining value. So what I am left with, I'm left with a sine beta cos beta minus of, not minus, it's plus sine beta into 1 minus a cos beta. So I'm also opening it. So it is sine beta minus a cos beta sine of beta in the numerator, and let's have a look at the denominator. So in the denominator, what I'll be getting it, the first term would be cos beta into 1 minus a cos beta, 1 minus a cos beta. So I get cos beta minus a cos beta into cos beta is a cos square beta, and the other term is minus a sine square beta. Now this and this will be cancelled out because it is one and the same thing. So also one thing here is to be noted, that if I'll be taking my minus a common, so we'll be left with cos square beta plus sine square beta, that is nothing but 1. So we'll be using that value. So I'll be using that value. So what is the ultimate value of tangent of alpha plus beta? That I get sine beta upon cos beta minus a, because inside it will be cos square beta plus sine square beta, that is 1. So this is the value. Now looking at the options, we can see that this is sine beta upon cos beta minus a. It means that this can't be the correct option because this is one of the value. Now what I'll be doing here is that I'll be considering the case 2 which I was talking about. So case 2, in case 2 I'll be using the value of tan alpha, that is sine alpha upon cos alpha, and I'll be using the value of tan beta as what we have found out in equation number 3. So let's solve that. Again, tangent of alpha plus beta, so that is tangent alpha, that is sine alpha upon cos alpha, plus what is tan beta? So tan beta is, that is sine alpha 1 minus cos beta upon a cos alpha cos beta. So this is the value what we have found out in equation number 3. This now this is in the numerator, and what would be in the denominator? So in the denominator it would be 1 plus 1 minus, apologize for this, this is 1 minus sine alpha upon cos alpha and sine alpha into 1 minus cos beta upon a cos alpha cos of beta. Now again I'll be taking the LCM. Now one thing again, the same is to be noted, that the LCM would be same both, that is cos alpha into a cos alpha cos beta. Again here it is also the same, so we'll be cancelling out, so I'll be writing down the final value. So what is the final value? That is a sine alpha cos beta, I'm taking cos alpha common, cos beta plus sine of alpha minus a sine alpha cos beta, this thing into sine into cos of alpha, which is common in all the three terms. This is in the numerator, and what is in the denominator? So I am getting in the denominator, what is the value? It is a cos square alpha cos beta minus sine square alpha plus a cos beta sine square alpha. Now this term would be cancelled with this term, so in the numerator what we are left with sine alpha cos alpha. Now let's have a look at the denominator. Now it is minus sine square alpha, that I'm writing as it is. Now as far as this and this is concerned, so what is common? So the common is a cos beta, I'm taking common. Inside it is cos square alpha and sine square alpha, that is 1, so it is like this. So what is the final value? That is sine alpha cos alpha upon a cos beta minus sine square alpha. Let's have a look at the options. So this is also in one of the options. So it means that option 1 and option 2 are the values of tangent of alpha plus beta. So this option 2 and option 3 is similar, but there is only difference in this sign. So this cannot be possible. Therefore, which is not the value of tan alpha plus beta? So I'm writing down option C. So therefore, option C is the correct option. I hope this explanation is clear to you. So C is correct. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।